we are going to start a new chapter of physics, that is electricity. Topics which we are going to discuss in this chapter are charges and its types, conductors and insulators. Then we'll discuss electric potential and potential difference, electric current, electric circuits, in which we'll discuss about circuit diagrams also, Ohm's law with its experimental verification, resistance and the factors upon which resistance depends, combination of resistances both in series as well as in parallel combinations. Then we'll discuss domestic electric circuits, then electric power and heating effect of electric current and its applications. Now you know that electricity is an very important source of energy in the modern times. It's used in our homes, in industry, in transport, even electricity. It is used in our homes for lighting, operating fans, heating purposes. Even in industries, it's used to run various types of machines. In transport sector, electricity is being used to pull electric trains. Sorry. So, electricity is nothing but the presence or flow of charge. Now, what is this charge? So, first of all, we should know something about electric charge. So, let's discuss about the electric charge. Charge is represented by the symbol Q, and charge is nothing but it is the property of matter, is a characteristic property of matter. Okay, as you must have observed that if we bring a plastic comb near some very tiny pieces of paper, it will not have any effect on them. But if, however, the comb is first rubbed with dry hair and then brought near the tiny pieces of paper, we'll find that the comb will attract the pieces of paper towards itself. So, what this observation conveys? This observation explains that initially the comb was neutral. That is why it has no effect on the tiny pieces of paper. But when the comb is rubbed with dry hair, it gets electric charge because of rubbing, and then this electrically charged comb exerts a force on the tiny pieces of paper and attracts them. So it means by rubbing that comb occurs a kind of charge. So it is a property of matter by which it can experience forces. It can exert force. So we are having two types of two types of charges. One is positive charge and another is negative charge. There's one more important property of charges, that is like charges repel each other and unlike charges attract each other. Now, like charges means same charges. If you are having both charges as positive, and or you can say both charges are negative, then these are same charges and similar charges always repel each other. But if you are having unlike charges, it means one is positive and another one is negative, then that unlike charges, that opposite charges will attract each other. And the SI unit of charge is coulomb. This is the unit of charge in which charge is measured, and it's denoted by the letter C. Okay. Now, you know that in an atom we are having three subatomic particles: electrons, protons, and neutrons. Electrons are negatively charged particles, protons are positively charged particles, and neutron is having no charge. It's neutral. Okay. Now, uh, all the matter contains protons as well as electrons and neutrons. This proton also possesses a charge, positive charge. Electron possesses a negative charge. Now, how much charge does proton contain? How much charge does electron contain? So, electron possesses a negative charge of 1.6 into 10 raised power minus 19 coulombs. And protons also contain the same charge but positive. Proton possesses positive charge of 1.6 into 10 raised power minus 19 coulomb, and electron also possesses a charge but a negative charge of 1.6 into 10 raised power minus 19 coulomb. Okay. So now it is obvious that the unit of electric charge, that's coulomb, is much bigger than the charge of proton or the charge of electron, because this is the less unit. You can see that this value is very less. So 1 coulomb is bigger unit, bigger than the charge of electron or the charge of proton. Now, how can we calculate the number of electrons that are present in 1 coulomb of charge, or how many electrons are present in 1 coulomb of charge? Now see, when we are having charge of 1.6 into 10 raised power minus 19 coulomb, that means we are having only one electron, because it is the charge of one electron, or it is the charge of one proton. So when number of electrons is 1, you are having a charge of 1.6 into 10 raised power minus 19 coulomb. Now I want to find the number of electrons present in 1 coulomb. So our charge is here 1 coulomb. The number of electrons will be 1 divided by 1.6 into 10 raised power minus 19, right? So while dividing, we'll get 6.25 into 10 raised power 18 electrons. It means 6.25 into 10 raised power 18 electrons, when taken together, they constitute 1 coulomb of charge. It means 1 coulomb charge contains how many electrons? 6.25 into 10 raised power 18 electrons. Okay. You can also find this value by using this formula. Q is equivalent to N into E, where Q is nothing but charge, N is the number of electrons, and E represents the charge on one electron. That you know, it is equal to 1.6 into 10 raised power minus 19 coulombs, right? So see, coulomb is a very big unit of electric charge. Okay, it is much bigger than the charge on one electron, or you can say the charge on one proton. Okay. Now here we are going to discuss about electricity, right? And electricity is classified into two parts: static electricity, or you can say current electricity. What happens in static electricity? The word static means the something at rest, stationary. So what happens in static electricity? Electric charges are at rest, or you can say stationary. They do not move. Suppose I told you about if you are having a scale and you are rubbing it with your hair, then you will see that the tiny pieces of paper will attract the scale. So it means while rubbing, the scale occurs some kind of charge, but those charges do not move. They are stationary charges. They just experience a force on these tiny pieces of paper so that they will attract, but they don't move. So it means that kind of electricity, that kind of charges are nothing but static electricity. So the charge occurred by this scale is nothing but an example of a static electricity, because these charges do not move. Even you can take another example. For instance, you are having a glass rod, and when you rub that glass rod with a silk cloth, you will see that the glass rod becomes charged. And again, that is an example of a static electricity. Okay, even the lightning which we see in the sky during rainy season, that also involves static electricity, because charges actually do not move. They are static, they are at rest. Okay. And what happens in current electricity? Electric charge are in motion, and because of that they produce an electric current. So electricity which we use in our homes is current electricity, because in that electrons are charges are in motion. And we are going to discuss current electricity here. So in this chapter, we'll discuss only current electricity in detail. So when we talk of electricity in these discussions, it will actually mean current electricity. Okay, thank you.